Welcome back everyone to another video here on the Unknown Coder YouTube channel. Today we are doing another LeetCode problem. This time around we are doing find the index of the first occurrence in a string. This one is an absolute mouthful, and if you actually take a look, this is only accepted about 40% of the time. So some people do have a little bit of trouble with this one. Hopefully I can demystify it a little bit. So this problem states that you're going to be given two strings, the first one called needle and the second one called haystack. We want to return the index of the first occurrence of needle inside of haystack, otherwise return -1 if that does not exist. So basically we are looking for a string inside of a string. We can go ahead and hop down below and take a look at a couple of examples before talking about our constraints and the other things. So for our example number 1, we're going to be given a haystack of sad but sad, and we're going to be given a needle of sad. So inside of haystack we're going to be looking for the word sad, and if we actually take a look, we'll see the word sad right here, we'll see the word sad right here. Now it wants the first instance, so it'll be this one, and this one starts at index 0, so we'd return 0 here, and that would be that one. Let's go take a look at the second example. For example number 2, we're going to be given the haystack equal to LeetCode, and our needle will be equal to LeetCode. So even though we do have leet right here and leet right here, we have to match the entire string. So nothing matches here. So this one would actually return -1. So those are our two examples. Let's go up and take a look at our constraints and then try to figure out how we're going to solve this. So back up here, we just have two constraints. The first one being 1 is less than or equal to haystack to length, and needle of length is less than or equal to 10 to the 4. So all of this is saying is that the length of either word or string, whatever you want to call it, is between 1 and 1000. So nothing too crazy on that one. The second constraint says that haystack and needle consist only of lowercase English characters. This is just telling us that we don't have to deal with any weird cases or anything like that. We're only going to be dealing with the regular old English alphabet. So with all of our information, our goal is to go ahead and loop through the entire string that is called haystack and determine whether or not an exact string called needle is contained within that string called haystack. Now there are a couple ways to approach this problem. We could either cheat the problem and just use the included method called indexOf, which is basically what we're trying to implement here, or we could use a technique called the sliding window technique, where we can try to match the string we are looking for inside the haystack based on the size of that needle string. So let's go ahead and take a look at the pseudocode for the sliding window technique, because I don't really feel like cheating. That won't really help you much. And then we'll go ahead and take a look at the example walkthrough and hop onto LeetCode after that. What we want to go ahead and say is for each character in the haystack string, we want to say if the current character in haystack is equal to the current character in needle. If this is the case, we want to increment the current needle character index. Otherwise, we want to go ahead and reset that current character index and reset the needle character index as well. Then if our needle index has reached the length of needle, then we want to go ahead and return the first index of that matched string. If we don't return from this loop, we'll go ahead and return -1 at the end. So that is what our pseudocode will look like. So let's go ahead and walk through our example just to show that it's going to work. Once again, we'll do the example of haystack equal to sad but sad and needle equal to sad. Now we're going to want to go ahead and loop through each character in haystack. So for I equal to 0, our h index is equal to 0. Otherwise known as the haystack, and then the n index or needle index is equal to 0. In this case, haystack char at 0 is equal to s, and our needle.char at 0 is equal to s. So they're the same, so go ahead and increment our n index. We're also assuming this is a for loop, so we're also going to iterate I as well as the h index. So I equal to 1, our h index is equal to 1, and our n index is equal to 1. So now our haystack.char at 1 is equal to a, and our needle.char at 1 is a. Once again, they match, so we'll go ahead and increment our n index. Now we'll go ahead and say I equal to 2. H index is now equal to 2 as well, and our n index is equal to 2. So now our haystack.char at 2 is equal to d, and our needle.char at is equal to d. So once again, we'll go ahead and increment n index. Now we'll go ahead and check and say, oh look, n index is equal to needle.length. This means we found this string in here, so we'll go ahead and return I minus needle.length, which ends up being 0, which is in fact that first value right here. So that works out. Obviously this wasn't a super crazy complicated one, but it also works for the other ones. Let's go ahead and hop over to LeetCode and take a look at coding this. So over on LeetCode, we're going to set up a couple things. Well, first, I'm going to put this into Java for one. Then we also make this a little larger. All right, there we go. So first, we're going to want an int h is equal to haystack.length. Then we want an int n is equal to needle.length. And finally, we want an int n index is equal to 0. Then we want to say for int I is equal to 0 and I is less than h, I plus plus. We want to say if haystack.char I is equal to needle.char in index, go ahead and increment in index. Otherwise, we want to say I equal to I minus in index, We're basically resetting the index so that we can start counting again with this sliding window. We'll also go ahead and say in index is equal to 0. Then outside this else, we'll say if in index is equal to n. This means that we have the length is equal to the number of indexes that we counted. So then we'll go ahead and return I minus n plus 1. And then outside of this for loop, we'll return -1 because we did not find an answer. Fingers crossed I didn't typo anything. Everything looks good. It looks like I did typo this. And I think the rest of that looks good. So hopefully no other typos. Let's try to submit. And there we go. We get a 0 millisecond runtime using an actual solution that doesn't use the index of value on the string. So that is also great. So if you feel like you've gotten any value out of this or just enjoyed it, please make sure to like, comment, and subscribe. Everything helps out in this YouTube journey. As always, my name is Ethan, Unknown Coder. Hope you all have a great day, and I'll see you in the next video.